Mungkin lihat begitu dibuka, oh ini virus Indonesia lebih ganas-ganas untuk menewe.
Selamat siang, ada budekan ini, Prof. Widodo.
Iya.
Prof. Widodo, mana Prof. Widodo?
Selamat siang, assalamualaikum.
Waalaikumsalam warahmatullahi.
Itu tidak asing itu Bu Widodo, Pak Anton.
Alhamdulillah.
Pak Anton yang kemarin dulu itu loh ya. Kita
betul.
Bincang-bincang ya.
Dia dulu ngobrol juga pernah, tapi waktu saya masih di Malaysia di UKM.
Iya, benar.
Nanti kalau
Malaysia
sudah kondusif main ke Semarang sini Pak Anton.
Ya, insya Allah.
Iya.
Dekat ini saya orang Brebes soalnya.
Iya.
Kalian pulang kampung, ya, pulang kampung ya.
Dari Brebes Semarang kan paling
iya.
Setengah jam
2 jam lebih ya naik kereta api itu cepat.
Nah, istri udah gabung tuh ya Pak Anton ya? Iya,
ada di sini. Ya datang kemarin ya bulan apa itu? Waktu masih dibuka bulan September, Oktober ya.
Iya.
Begitu dibuka langsung saya suruh datang gitu. Karena waktu itu pas pulang jadi terjebak di Indonesia.
Oh iya, itu bukan
pas Januari pulang kan. Iya. Januari pulang.
Udah pakai artificial intelligence sengaja dijebak Pak Anton. Aja mulai.
Aja mulai.
Yang
di sana ini ya banjir ya. Saya baca berita di Semarang banjir itu. Betul.
Iya, banjir Pak itu kalau hujan deras 2 jam sampai 4 jam itu ya udah menggenang itu bawah itu.
Iya, berarti daerah Simpang 5 gitu ya.
Iya. Tapi ya cepat surutnya Pak.
Oh, cepat surut.
Ya cepat surut dipompa itu loh.
Iya betul, harus ada truknya yang pompa itu. Udah kayak di Arab Saudi aja. Di sini kalau hujan sebentar banjir, truknya datang nanti pompa.
Oh iya dong.
Karena di Saudi itu kan nggak punya selokan. Dia kan nggak didesain untuk hujan negaranya.
Oh iya.
Jadi kalau
pasir.
Iya. Soalnya apa? Kalau ada selokan pasir penuh dengan pasir, Pak. Kan tiap hari badai pasir berterbangan sama sini.
Ya?
Iya.
Malah capek ngeruknya Pak Sapto.
Capek ini. Iya, capek ngeruk ini pasirnya.
Iya.
Sementara hujan kan nggak sampai 10 kali setahun.
Iya, kalau
jarang ya hujan ya.
Jarang ya.
Dan badai ya Pak sana kalau hujan ya badai.
Ya, kadang-kadang ya campur badai, kadang-kadang ini kan hujan hujannya itu ini juga badainya badai pasir soalnya. Jadi yang agak repot.
Iya. Panas ya.
Iya, ini jadi kayak kabut gitu Pak Sapto, enggak kelihatan apa-apa, gelap.
Iya.
Ya karena partikel pasirnya ini kan kalau banyak kan jadi gelap.
Iya.
Enggak, jarak pandangnya pendek, makanya bahaya kalau penerbangan kan begitu badai pasir ditutup airport.
Bahaya ya.
Karena ini kan mesin ini kapal. Iya.
Engine ya.
Engine-nya betul masuk ke baling-baling apa semua.
Pak Anton, ini penampilan agak sedikit berbeda nih sama terakhir kita ketemu ya. Dari Pak Anton ini sudah kayak Habib ini bawahnya sudah. Ya, gue tambah keren ini. Kayak kelihatan ilmunya sudah semakin dhuwur gitu. Mantap lah. Ya. Saya juga
ini padahal baru 3 bulan nggak digunting Pak, baru 2 bulan tidak dicukur, 2 bulan 3 bulan. Iya, kemarin waktu lockdown itu karena sekarang kan ketat sekali ya, mau ke tukang cukur itu harus buka aplikasinya. Iya,
cukur
ini dikontrol ya, cukur sendiri ya kalau
dicukurkan istri.
Rambutnya gondrong.
Iya. Ya banyak sih selama pandemi itu aku lihat ya bodoh pangling itu. Oh itu bilangnya Mas Pak Teguh itu Mas Teguh. Itu nggak berani buka masker loh, Mas.
Gunting, Pak.
Wah,
Baru
ini
2 bulan
brewokan
tidak
ya,
dicukur,
lu.
2 bulan tidak
Bagus lah saya bilang gitu. Nah, Mas Teguh udah gabung belum nih, Mas
Kemarin
Teguh?
waktu lockdown.
Belum ya.
Sampun Pak Sapto.
Oh iya, lah
Ampun.
mana ini?
Mulai jam
Wah,
berapa
nggak
ini?
tampil loh
Mulai
videonya.
jam berapa ini Pak Sapto?
Sudah.
Ya,
Saya
ini
sudah
masukin.
cukuran. Sudah cukuran Pak, udah berani.
Hai. Iya, iya.
Nah, gitu.
Ah, gitu dong.
Darmanti
Ya,
mana
ini-
Darmanti?
Darmanti. Ya. Oh, ini nanti yang setting kayaknya ini masuk ke bilik ya? Bilik khusus ya Pak Ruli?
Iya, gimana?
Kita ini masuk di bilik yang khusus ya. Di kanal khusus
Room
ya.
utama, Pak. Mohon maaf.
Utama kelihatannya Pak
Room
partisipan.
utama, Pak.
Oh ya. Kenapa nggak digeser dulu? Ini nanti peserta pada dengar pembicaraan kita.
Sudah tadi dari awal, Pak.
Oh iya. Sekarang gimana? Udah di display belum nih?
Sudah siap untuk dilaksanakan, Pak.
Ya. Split aja dulu. Masuk ke ruang apa ya? Guest house. Guest house.
Breakout room.
Breakout room.
Campur ini kayaknya. Campur ini Pak Sapto, nggak dipisah.
Makanya di breakout room dulu.
Nah, ini sebentar lagi paling mulai Pak Sapto.
Iya, dimulai aja lah wis Pak Sapto. Ya komplit toh. Nggih Prof. Prof Idawati dimulai aja ya kayaknya ya.
Betul, saya kira kalau dimulai lebih bagus. Ini pesertanya juga
Bisa dimulai mungkin ya.
Okay.
Silakan.
Excellencies and distinguished participants, please be comfortably seated as we're about to begin our Studium General. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Warahmatullahi wabarakatuh.
Salam warahmatullahi wabarakatuh.
I hope all of us in a healthy conditions. First of all, I would like to introduce myself. My name is Gundis. I will be the MC of the Studium General this afternoon. The Honorable, the Dean of Faculty of Science and Mathematics, Diponegoro University, Madam Professor Dr. Widawati, SSC M.Si, the Honorable Head of Biology Department, Faculty of Science and Mathematics, Diponegoro University, Professor Dr. Endah Dwi Hastuti, M.Si, our respectable speakers, Sir Professor Dr. Anton Satria Prabuwono, and Sir Associate Professor Sapto Purnomo Putro, Ph.D, our moderator, Sir Ruli Rahadian, M.Si, Ph.D, our respectable lecturers of Biology Department, Faculty of Science and Mathematics, Diponegoro University, and distinguished participants. On behalf of Biology Department of Faculty of Science and Mathematics, Diponegoro University, I would like to extend my welcome to every participants for giving our presence to our online Studium General with the theme Information Technology-Based Innovations in Biological Science. Before starting our Studium General, allow me to inform you about the agenda. To begin our agenda, we'll pay our respect to our national anthem and march of Faculty of Science and Mathematics, Diponegoro University. Next up, to officially open our agenda, we will hear a welcoming remark from the Head of Biology Department, Faculty of Science and Mathematics, Diponegoro University, Madam Endah Dwi Hastuti. To follow, we will hear a remark from our Dean of Faculty of Science and Mathematics, Diponegoro University, Madam Widowati. Next up, we will have a documentation session, followed by our primary agenda, that is a presentation and discussion by our speakers, led by our moderator, Sir Ruli, Ph.D. After that, we will have announcement and closing. Now, Excellencies and distinguished participants, we will pay our respect to our national anthem, Indonesia Raya. Thank you. Faculty of Science and Mathematics, Diponegoro University, always aim to strive on a constant change of the world. As Faculty of Science and Mathematics, Diponegoro University, prepare ourselves to welcome the fourth industrial revolution. Our students, research, lecturers, and alumni will walk in a perfect harmony to reflect how proud we are as a part of Faculty of Science and Mathematics, Diponegoro University. Therefore, we will pay our respect to a march of Faculty of Science and Mathematics, Diponegoro University, Mars FSM Undip.
Harapan nusa bangsa dari penjuru Indonesia, menggapai ilmu alam semesta, tak mengenal kata putus asa, bersinergi dalam cita, kobarkan semangat dalam dada, FSM terus berkarya, membangun alma mater tercinta. Watak Diponegoro tercipta, warna tekad di dalam jiwa, iman dan takwa sebagai bekal, amalkan ilmu ke seluruh dunia, bersinergi dalam cita, kobarkan semangat dalam dada, FSM terus berkarya, membangun alma mater tercinta.
Thank you. Excellencies and distinguished participants, to begin, we would like to invite Madam Professor Endah Dwi Astuti as the head of Biology Department, Faculty of Science and Mathematics, Diponegoro University, to deliver an opening remark to officially open our Studium Generale. Madam Endah, the time is yours.
Thank you, Mbak Gendis. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
To the honor, the Dean of Faculty of Science and Mathematics, Professor Dr. Widowati. To the honor, Professor Dr. Anton Satria Prabuwono as resource speaker. To the honor, Associate Professor Sapto Purnomo Putro, Ph.D. as the resource speaker. To the honor, ladies and gentlemen, all lecturers, all the invitees, and all students. Thank you to Allah Subhanahu wa Ta'ala. Today we can meet to carry out the online with the theme Information Technology-based Innovation and Biological Science, presented by Professor Dr. Anton Satria Prabuwono from the Faculty of Computing and Information Technology and Rabbit, King Abdul Aziz University, Jeddah, Saudi Arabia. Welcome, Prof. Anton. Thank you for taking the time to share knowledge on this opportunity. Even though our activities today are carried out online, hopefully doesn't dampen our enthusiasm to increase knowledge. Ladies and gentlemen, the Studium Generale activity is held as part of Department of Biology's effort to complete the performance targets mandated by Diponegoro University. In particular, we hope that this activity can bring an important impact, especially increasing insight into the field of biology in relation to artificial intelligence technology, which is currently popular, and we must learn about it. We need to know artificial intelligence technology in order to provide information to all of us about the development in application for biological studies. The area of digitalization requires us to bring the study of biology to link it with the Internet of Things. We hope that all the participants can follow this activity till the end. Professor Anton will deliver material on artificial intelligence inspired by biological system, which will be continued by the second speaker, DRS Sapto Purnomo Putro, Ph.D., who specifically discussed about developing software for biomonitoring as a warning system of water ecosystem. Maybe today we will see the development of artificial intelligent technology from the aspect of biomonitoring. Hopefully, in the future, we can discuss furthermore about the application of the aspect of biological studies. Ladies and gentlemen, we would like to thank to the Dean with support for this activity, to the entire committee team who have been willing to organize this activity, especially our appreciation to Pak Sapto, Ph.D., who is willing to be the communication liaison with Prof. Anton. Hopefully, this activity can be followed up with other broader activities in the form of Tridharma Perguruan Tinggi Cooperation. In the form of research and others. Ladies and gentlemen, it is our welcoming speech that we can convey. Thank you for your participation. Congratulations on participating in this Studium Generale activity. Hopefully, it will be useful for all of us. We apologize for any inconveniences during our delivery. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you for the remark, Madam Enda. Now, we would like to invite Madam Professor Dr. Widowati, SSC M.Si, as the Dean of Faculty of Science and Mathematics, Diponegoro University, to give a remark. Madam Widowati, the time is yours.
Thank you very much for Master of Ceremony, Ms. Gendis. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Excellency, Professor Dr. Anton Satria Prabuwono from Faculty of Computing and Information Technology in Repih King Abdul Aziz University, Jeddah, Arab Saudi. Thank you very much for joining in this event, Professor.
Thank you. Welcome.
Yes. Excellencies, Associate Professor Sapto Putro, Ph.D, as a head of Center of Marine Ecology and Biomonitoring for Sustainable Aquaculture, and as a senior lecturer at Biology Department, Faculty of Science and Mathematics, Diponegoro University. Thank you, Associate Prof. Sapto.
You're welcome. You're welcome.
Honorable Professor Dr. Indah Dwi Hastuti, M.Si, as a head of Biology Department, Faculty of Science and Mathematics, Diponegoro University. Also, Dr. Wijanarko, M.Si, as a Secretary of Biology Undergraduate Study Program. Honorable Ruli Rahadian, M.Si, Ph.D, as a moderator. Dear lecturer at Department of Biology and all participants. It is my great pleasure to cordially welcome you to the Biology Department Studium Generale event 2021. After careful consideration for the growing travel and health concerns surrounding the spread of coronavirus disease or COVID-19, this Studium Generale is conducted virtually. First of all, let us thank to Allah Subhanahu wa Ta'ala, the most gracious and merciful God, because with His permission today, we can gather here to join together for online Studium Generale events. My sincere gratitude, especially to Professor Dr. Anton Satria Prabuwono and Associate Professor Sapto Putro, Ph.D, who will be today's speakers, and to all participants for their great contribution in promoting biology, sciences, and technology information for Diponegoro University Academia. In addition, for today's Studium Generale, the material was specially prepared by speakers about information technology based innovation in biological science. The purposes of these events are to give insight for Studium Generale participants about the importance of the information technology, especially those related to the field of biological sciences. To know the application of artificial intelligence in biological studies, especially by monitoring of aquatic ecosystem. And then to know the software for biomonitoring data analysis of aquatic ecosystem. Ladies and gentlemen, it is an honor for us to get a direct lecture from Professor Anton Satria Prabuwono, and Associate Professor Sapto P. Putro with topics artificial intelligence inspired by biological systems and developing software for biomonitoring as early warning system of water ecosystem. I want to use this opportunity to congratulate the head of biology departments, lecturers, and also students for their foresight in choosing as the best lecturer at the topic that has a national relevance and in working very hard to make this event a reality. As we know that the vision of the Faculty of Science and Mathematics, Diponegoro University, is become an excellent research faculty with international reputation in the field of science and mathematics and the development of this application. So this event strongly supports our mission to prepare students who have excellence, ethical, national skill in the field of biology, information technology, and its application to produce competitive graduates at the national and international level. I would like to thank all the students of Diponegoro University and all participants for staying home and staying safe amidst the coronavirus outbreaks. I hope that you, your loved ones, and all of us are safe and well. I pray this COVID-19 will pass soon so we can return to our usual activities. Amen. Finally, I want to heartily welcome you to this event. It is my pleasure one more time to say thank you and welcome in Studium Generale event of Biology Department. I hope this Studium Generale events can inspire many scientists to improve their research and open international collaboration between institutions. Last but not least, by the grace of God Almighty and consent of all participants, on behalf of Faculty of Science and Mathematics, Diponegoro University, I am as a Dean hereby announce that online Studium Generale event with the topics Information Technology, Best Innovation in Biological Science is open. I encourage all participants to participate actively in the interesting discussion. Hopefully, what we are doing today is useful for our progress in the future. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Madam Widowati, for the speech. Next on our agenda is a photo session. I would like to invite all of us to open our camera and show our best pose. And I will lead the session by counting to 3, and the screenshot will be taken by the committee. There are some slides on Zoom, so please hold your pose until a signal is given by the committee. All right, please open your camera so that we can all in the documentation of this study in general. All right. Thank you. I will start. Oh, wait, I will wait for a while. Okay. Thank you for opening your camera. All right. All right. We will start the screenshot. Please give your best pose. 1, 2, 3. Please hold. Please hold for a while. Please hold. Please hold for a while.
Finish.
Okay, thank you. All right. Dear distinguished participants, we are going to proceed to our primary agenda. That is a presentation and discussion with our keynote speakers. There will be 2 sessions. The first will be a presentation from Sir Professor Dr. Anton Satria Prabuwono with the title Artificial Intelligence Inspired by Biological Systems. And the second session, we will have a presentation from Sir Associate Professor Sapto Putro, Ph.D. under the topic Developing Software for Biomonitoring as Early Warning System of Water Ecosystems. Because of these fascinating topics that we are about to discuss, I would like to remind all of us to stay focused throughout our discussions and prepare your best questions for our awesome speakers. All right, I would also remind the participants that the attendance list will be up on the chat room so that you might want to find it there. But right now, I would like to introduce you to our moderator. That is Sir Ruli Rahadian, M.Si, Ph.D. He is one of the lecturer of biology department, FSM Diponegoro University, and his focus is on ecology laboratory, primarily on entomology. Now, without further ado, I invite Sir Ruli to lead our discussion.
Okay, thank you very much, Gendis, for introducing me. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, all. Well, today we have 2 prominent keynote speaker, and the first one will be invited speaker, Professor Dr. Anton Satria Prabuwono, and here there are also 2 title degree, but I'm not so familiar, SMIEEE and SMACM. Maybe Prof. Anton could explain what kind of title degree here. Prof. Anton, actually, he is Indonesian. He came from Brebes, right? From Brebes. Yes. But currently, Prof. Anton is a professor at the Faculty of Computing and Information Technology in Rabi, King Abdul Aziz University, Jeddah, Saudi Arabia. Okay. He started his academic career at Institute of Electronics, National Chiao Tung University, Taiwan, and also Faculty of Information and Communication Technology at University Teknik Malaysia, Melaka in 2006 and 2007, respectively. Then he joined the Faculty of Information Science and Technology, University Kebangsaan Malaysia in 2009. Then also, lastly, I think he joined the Faculty of Computing and Information Technology in Rabi, King Abdul Aziz University until right now, I think. He got many awards. For example, Best Publication Award from UTM, yeah, University Technique Malaysia Melaka, yeah, in 2008, and then he received Excellent Service Award from UKM also in 2010, and IEEE Gold Best Paper Award at IFIC 2011, Best Paper Award at ICEEI 2013, and IEEE SMC Society Distinguished Lecturer in 2016. And he appointed as an Outstanding Scientist Award in 2016 from Venus International Foundation, India. Prof. Anton also has experience as a visiting professor. Actually, this is the Erasmus Mundus program at the Department of Mechanical Engineering and Mechatronic, Karlsruhe University of Applied Sciences, Germany. Yeah, he also a guest professor at Robotic Lab, Japan Advanced Institute of Science and Technology. Yeah. In addition to his academic experience, he also has more than 6 years of experience in several multinational companies such as Bhumikaya Steel Industries, Samsung Electronic Indonesia, and Coca-Cola Bottling Company. His last position was technical manager at Coca-Cola Bottling Indonesia in Central Java. Okay, I think no doubt his expertise is very, very good, right? And then today, he will present about artificial intelligence inspired by biological system. Okay, Prof. Anton, it is the time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
So thank you to Dr. Ruli, and also thank you to the Dean of Faculty of Science and Mathematics, Diponegoro University. Yeah, and also to the head of Department of Biology, yeah, Prof. Endah and Prof. Widowati, yeah, as the Dean. Right, and also thank you to Associate Professor Sapto, yeah, because he's actually my friend, yeah, from the same origin, yeah, ngapak. Ngapakers. Yes, actually I miss to speak in Java language, yeah, since here it's been long time. I mean, almost 1 year I didn't speak in Java language. Yeah, that's why I expect to speak in mother language and also in, yeah, of course, in Bahasa Indonesia and Java. But then, okay, since this is maybe as an international event, something like that, consider as an international event. So, yeah, I try to deliver this speak in English because every day I speak in English here. Yes. And I don't speak Arabic well, so that's why I speak in English here. Yeah. Even in teaching, every day I speak in English. All right. So thank you for inviting me, and to deliver the speech today, yeah, in online Studium Generale, Biology Department, Diponegoro University, Indonesia, Semarang. All right. So I try to open slide. Okay. Bismillahirrahmanirrahim. Can you see my slide, my screen?
Yes. Yes, already appear.
All right. Okay. So, okay, and thank you for attending this event. Yeah, right, to all the participants. So, my talk today, entitled Biologically Inspired Artificial Intelligence. Actually, I'm going to talk about the concept and the applications, yeah, since it is actually not really new, yeah, this technique or method. Even even we call as the new AI, but actually not really new because of the old one, the old version we call as the symbolic AI, symbolic artificial intelligence, the conventional or the classical method. And then the new method we call as a biologic or bio-inspired artificial intelligence. Okay, so my name is Anton Satria Prabuwono, and I'm a professor in the Faculty of Computing and Information Technology in Arabic, King Abdulaziz University, Jeddah, Saudi Arabia. So Rabic is actually the small city, the north part of Jeddah. So it is like a branch campus. Yeah? So then the main campus is in Jeddah actually. So we have some faculties here in Rabic town. Yeah, so that's why we call as a Faculty of Computing and Information Technology in Rabic. Yeah, because we have also Faculty of Computing and Information Technology in Jeddah. So we have 2 faculties of computing actually here. Right, so this is my short biography. Actually, Dr. Uli has mentioned. So I'm originally from Brebes, Central Java. Yeah. I think around maybe 160 kilometers from Semarang. Not so far, only 2.5 hours by train. Maybe nowadays because we have what's that, the highway from, I mean the Java maybe, yeah, from all over the Java island. So it is very easy to go from Brebes to Semarang, yeah, and also from Semarang to Brebes. Right. So this is my background, yeah, the academic background. So I have 2 bachelor degrees, I have 2 master degrees, I have 2 professional degrees in engineers, and as well as PhD. I have 1 PhD, but then actually I took the second PhD, but I didn't continue the second one, yeah, in electronic, yeah, since I have a problem to settle the family things. Yeah, so then I have to come back to Malaysia at the time. So then I discontinued my PhD, my second PhD. Right, and then I have experience also more than 6 years in industries, and then my last position was actually in Semarang, in Ungaran, Coca-Cola Bottling Indonesia in Ungaran. So I was a technical manager over there. And then I have a teaching experience, teaching and research experience more than 14 years. And then the research areas cover machine vision, artificial intelligence, especially intelligent robotic and autonomous systems. And the publication more than 200, including books, book chapters, journal and conference papers. And supervision, yeah, I have supervised more than 15, yeah, because of, I think maybe around 16 completed PhD student, mostly in Malaysia, yeah, and 2 PhD students still in progress right now. And professional services, yeah, more than I think 60 keynote speech and so on. And these are the awards and achievement. Yeah. So since 2005, you know, because of actually I've been more than almost 20 years, yeah, in overseas, yeah, since 2003 until today. So from 2005 until 2020, 2019, I got some awards and achievements. And so this is the outline of my presentation today. So I'm going to start with the introduction. Yeah, to introduce the artificial intelligence, and then continue with the bio-inspired artificial intelligence. So this is the concept and applications. So I will show some application of this concept, the bio-inspired AI, yeah, on the current, I mean the real world implementations, and then the conclusion. All right, so what is actually the AI? Then what is the basic knowledge of the artificial intelligence? Yeah, as I mentioned previously, so the classical artificial intelligence, we can say this one, the conventional method, or symbolic artificial intelligence. Actually, we need the knowledge like electrical, industrial engineering, and computer science, informatics, mathematics, and statistics. But then in new AI, in the era of bio-inspired AI, so we need the biology, the biology part. So actually the AI right now is the multidisciplinary research. So almost all the fundamental science involved in this kind of the research. So when I was in University Kebangsaan Malaysia, every month, in our center, Center of Artificial Intelligence Technology and Artificial Intelligence Technology, KAIT, Center of Artificial Intelligence Technology, KAIT. That is the name of the center. So we invited the lecturer or a professor from the biology department every month. Actually, what the purpose of that? So because we want to learn to study about the behavior of the organism, or animal, humans, and so on. So because of some algorithms actually inspired by the the behavior, the behavior of the organism. So that's why at the time we want to study about like bees, and then spider, and then bird, even monkey. So we have a algorithm called as the monkey climbing algorithm. We have a bees algorithm, we have an algorithm, so all these algorithms actually are inspired by the biological behavior, the organism behavior. So we have firefly algorithms, and then we have a DNA computing. So these are all inspired by the biological, biological science. So that's why we need the biological people in this part. So don't worry, we talk about the biology. Some part are biology, some part are computing. All right. So what is intelligence actually? So this is the example of IQ test. For the human, I think it is not difficult, very easy. Even elementary or maybe secondary or primary school, they can answer this question. So which one of the 5 choices makes the best comparison? Div is to devil as 6323 is 2. So we can very fast to answer this kind of question. So because we have intelligence as the human, so for sure, maybe less than 5 seconds, so we can answer this part. And the second one also, so as you can see here, maybe it takes around even less than 5 seconds. So you can see, okay, this is about the pattern. If this kind of pattern, then the next pattern will be what? So then we can answer this one very easy. And then the third one, maybe it takes more than 5 seconds, I think, because we need to calculate, to count this kind of thing. All right. So I think for the student of biology, it is not difficult to calculate, to count this kind of things. So based on this, for the human, it is very easy. This work is very easy. So not difficult, right? But for the machine, you can imagine how to train the machine, to answer this question. So we can imagine, So maybe if you don't learn about artificial intelligence, you never know about this kind of thing. But since you are a biology student, maybe you start to learn about the artificial intelligence in your department. So then some algorithm maybe you study about them. So in terms of the machine, it is very difficult, very hard to train. That machine can learn the pattern. So that's why we have the field of the pattern recognition under the umbrella of artificial intelligence. So how does machine recognize an object? Yeah. So we can see here one example. Can you see the video?
Oh yes, I can see it.
All right. But I'm not sure whether you can hear the sound or not of this video.
Only video without audio.
Only video, yes, yes, I think. All right, so in order to recognize the object, we have to train. We need to train the robot, yeah, this kind of object, right? So the first robot will not recognize, of course, yeah, because so we do not train yet the object to the robot. So then we have to enter what kind of object, I mean, in front of this robot or this machine. So we need to enter the features of this, the features. So the color, the shape, as well as maybe the size. So we have to enter this kind of thing, and we have to label this object. So then we have to repeat this kind of train many times. Then later on, the robot can recognize. It depends on how many times we train the robot. If we train many, so then it will be much accurate. If compare if we less train. If we give the less train to the robot. All right. So this is one example. And then the word of intelligence can be defined as follows. So this is based on the dictionaries. So actually the ability to understand, reason, perceive, or perception. I mean the human perception or any other things. And then quickness in learning, fast learning. Fast in learning is considered as intelligent as well. And mental awareness, ability to grasp relationship, level, information or informative, news, and so on. And the aspect of intelligence, humans are good at recognizing the patterns. Of course, as I mentioned earlier, on the slide that I asked, I put the question about the example of the IQ test. So it is very easy for us, right? So to recognize this part. So humans are good at recognizing the patterns. I think not only humans, maybe the animal also recognize the patterns. I think you know better than me about this. I mean the characteristic of the animals or the humans, because you are studying in biology department. So that's why we are the computing people, need the biology people to understand all these things. Humans are good at recognizing the pattern. So this one like flower. So for us, it is easy to recognize this kind of flowers, right? So, and then this one, the butterfly, and this one, the symbol or sign, traffic sign, and this one, another symbol. So it is easy, and we can remember these things. Maybe once we see this part, and after that we remember. Next time we see the same symbol, then we can recognize very easy, right? And then, again, humans are good at understanding even difficult handwriting, right? So I'm sure that you can easily, recognize the sign of your friends. That's why sometimes when we were in, offline, in the class, sometimes some student in the big class, they they learn the signature of their friends, then at the end put that signature. So that's why you can recognize very well the intelligence. I mean, in terms of the hand writing. So you can recognize, let's say, the first one in this signature or handwriting of, let's say, this is Farid. The second one belongs to Anton. The third one belongs to, let's say, Farhad. So we can very easy to recognize this part. But what happened with the machine? So it is not easy. Very, very difficult and very tough. So we have to train them many times, yeah, in order to be able to recognize this kind of signatures, yeah, or handwriting, handwritten. Yeah. And then these are the aspect of biological intelligence. So, it covers the capability to learn, capability to generalize or classify, and capability to survive. Yeah. So capability to survive is actually one aspect of the biological intelligence. Yeah. And then the recognizing pattern, understanding noise, reproduction, self-repair, self-guidance. Yeah. These are all the aspect of biological intelligence. Yeah, I think you can understand about this because so you are studying about this as well. This is one example of the application in, I mean, the natural, in terms of natural expression. Can you see the video?
Yes, you can see it.
All right. Okay, so this is one robot, yeah, and then yeah, see goal and what the expression next after this. So we can call this is as a natural expression, yeah, as a human being doing this kind of thing when they successfully to make a goal, yeah, right, to score this, I mean the competition, yeah, something like that. So actually spontaneous, reaction, this one. And then the next is about human, yeah, this is one thing, yeah. Humans have self-repair mechanism in their bodies. So then this is a very, very high level artificial intelligence, because of until today, the scientists still doing this kind of research, yeah, self-repair mechanism, right? So when, for example, this one, yeah, when you have some, this one, yeah, injection, yeah, and then the mark of the injection will be, recover, yeah, maybe within 1 day, then yeah, 1 day we can recover, yeah, from this kind of injection, yeah, for example from vaccine, this one, ya. Jadi kalau disuntik begini mungkin dalam sebentar sudah recover, ya, sebab ya because of the health, self repair mechanism in our body, right? So within, I think, less than 6 hours, yeah, then we can recover, yeah, after we got some injection, yeah, for example, or this kind of injection. All right. So what is artificial intelligence? AI is actually a tool, yeah, that has been developed, yeah, to imitate the human intelligence, yeah, human or animal, yeah, even. So, and the decision-making function, yeah, so providing the basic reasoning, yeah, and the human characteristic, yeah, or animal or nature, yeah, we can say it's the nature, because of nowadays we imitate not only the human, yeah, but also the animal, the nature, yeah, the weed, yeah. So yeah, this is the artificial intelligence. And then can machines be developed to have intelligence? Yeah, sure. So currently the scientists have many research about the machine intelligence. Yeah, so they try to imitate, yeah, the nature or human being or animal, yeah, and to apply in the machine, yeah, or any devices, yeah, that we have. So like this one, yeah, the social animals that are inspiring new behaviors for robot swarm. Yeah, so perhaps one way to do this is to develop the algorithms. Yeah, this is the way that we imitate, yeah, the human or the nature behaviors, yeah, organism behaviors. So we develop the algorithms based on the human or animal intelligence. Yeah, and then how do we design yeah, the intelligence. Right, so copying from the biological system, yeah. So this is one example, yeah, computer architecture. So the motherboard is actually consists of some layers. So it copied from the, you know, the skin layer of the human. So we have some layers, yeah, yeah, in the skin. So it copied by the computer architecture, yeah, the was that motherboard. That's why we have a dual cores, was it quad core. Actually, it is a layer of the motherboard. And copying from a biological system, yeah, another thing is like this, the aeroplane. Yeah. So it is actually copying from, yeah, the bird, yeah, of course. Yeah. At the beginning, we have the aeroplane like this. This is the first model of the flight. Yeah. But then nowadays we have very sophisticated aeroplane. And then copying from biological system, the next one is the human arm. Yeah, actually, I mean the robotic arms actually copied from the you know, the human arm. So as studied by uh, Yoshikawa in Kyoto University. Yeah. So he designed the optimal length of robotic manipulators. Yeah. So following the human arm, yeah, like this. So we got the robotic arm like this, yeah, in the on the right side, yeah, picture, right. And then the barcode, yeah, barcode actually copied from the thumbprint, yeah, from fingerprint of the human. So that's why barcode, yeah, you know, never be the same, yeah, from one product, one barcode compared to the other barcode. Yeah. Because so we are as human, even, you know, the population is around maybe 5 billion people. So yeah, there is no, you know, the same fingerprint, yeah, among us. And then the intelligence that can be designed as follows, yeah, the self-learning machines, self-organizing systems, and self-optimization, yeah, path planning, pattern recognition, decision making. So these are the type of the intelligence that can be designed, yeah, and can be embedded into the machine, yeah, so far. Because so the scientists still, you know, yeah, in progress to develop many things, yeah, to imitate or duplicate the behavior of human and animal and nature. And then how do we design the intelligence? Yeah, so we can study from the biological model, yeah, like brain, genetic, DNA, life, molecular biology. So then we have the neural nets, yeah, right now, neural networks, yeah, genetic algorithm, GA, artificial life. Yeah. So these are the kind of the algorithms actually, DNA computing and so on. And then we can study from the human phenomena. Yeah? So like common sense, reasoning, predicting, observing, yeah, inference. Yeah? So then we have a fuzzy logic, expert system, searching technique. Yeah? So these all are the algorithms inspired by the human phenomena. That's why. So when we want to design the intelligence, then we need to develop the mathematical or logical algorithms, based on the biological models or phenomena. And this is the diagram of bio-inspired intelligent algorithms. Yeah. So since if we want to design the intelligent system, then embed it into the machine, so we have to, you know, to create, yeah, to create or to design the intelligent algorithms, yeah, yeah, based on the biological, yeah, of course, biological phenomena or biological behavior. So bio-inspired intelligent algorithms. So we say is the BIS, yeah, BIA. So cover, we can divide into three parts actually. Yeah. So the first one is inspired by the organism behaviors. The second one inspired from the organism structure, and the third one inspired from evolution. So based on the organism behavior, yeah, it divided into based on the foraging behavior. So actually, this is the behavior of the animals, yeah, or organism to find the food. Yeah. So the algorithm and colony algorithms, yeah, bee colony algorithm, bacterial foraging algorithm, yeah, and then shuffle frog clipping, and then in terms of the other behaviors, so we have a firefly algorithm, yeah, bacterial chemotaxis algorithm, monkey climbing algorithm, and the second BIA is inspired by organism structure. So we have a DNA computing, artificial immune system, bio-inspired neural network, and then yeah, many actually. Yeah. So including the membrane computing, and then the last one inspired from evolution. So we have two parts. Yeah. The first one is based on the biological evolution. The second one based on the social evolution. So based on biological evolution, yeah, it includes this part, yeah, invasive with algorithm, chemical genetic program, yeah, selfish gene algorithm, coevolution, and so on. And then the second one, the example is a culture algorithm. And then the next is about the application. Yeah. So as mentioned on the previous slide, the category inspired from organism behavior, inspired from organism structure, inspired from evolution. So the name of the algorithm, so these are the advantages of this algorithm, and these are the application, as you can see here, for example, yeah, inspired from organism behavior. So we have monkey climbing. So these are the advantage of the monkey climbing algorithms, and these are the some application, yeah, of the monkey climbing algorithms. And then some application, yeah. The first one inspired by organism behavior. So the concept is actually to imitate the swarm. Yeah. So the swarm animal actually. So some animal societies display the coordinated and purpose, with the purpose, yeah, navigation. Actually, they have the behavior when they are looking for the food. Yeah. And then even though they are working based on the collective work, yeah, but then each individual uses local information. Yeah. So they don't have the long distance or long range sensor. So they just recognize the environment. Yes, only small distance, yeah, with the neighborhood. Yeah. So then based on this local information, then they decide. Yeah, they decide the decision. I mean, they generate the decision, yeah, in case of the there is a obstacle. Yeah. Yeah, that's why even though they work, in swarm, but we don't see the collision, yeah, the collide between this organism, right? So there is no predefined group leader, yeah, even though they don't have the leader, yeah, actually, yeah. But then we can see that this organism well organized, yeah, well organized in working together, yeah, in cooperation. So you can see this picture here, yeah, like flocking. This is bird, for example, and this is fish. The picture of fish. Yeah. However, in some cases there is a leader as well. Yeah. But then in terms of the leader, yeah, if they have a leader, then more restrictive rules. Yeah. Yeah, for the motion. Yeah, of course, because if there is leaders, then they will give the rules. Yeah, for the members. Yeah, so that's why. But still, they use the local information to recognize or to generate the decision. So this is if I talk about this, I remember, duck, bebek in Brebes, because of bebek is actually swarm, like this, working together, find the food, and then they share the food, and after that back to kandang, to every morning, after maybe 2-3 hours, and they got the food, and after that, back to the origin place. So these are the principle of swarm intelligence. So swarm can solve the complex problems, that a single individual with simple abilities couldn't solve. So if they work collectively, then they can solve the problem. So we have many things. Many applications about this. The swarm. So individual in swarm, have local sensory information and perform simple action. So these are some application. So this is the application in the character animation. So it's actually, this is following the animal behavior. So they copy the animal behavior, then they create the animation. That's why the behavior, like for example, this one lion, exactly the same as the original lion. And then we have also the particle swarm optimization. So this is the algorithm inspired by the bird flocking to find the best area of the food. And then trails, entrails. So how to recognize that the ant can return back to the home, after maybe long distance finding the food, and then they can return back to the home. So this is the technique. So the term, stigmergy, it is the term indicates communication among individuals, through modification of the environment. So some ant leave a chemical trail behind to trace the path. Actually they put something. They put something like us. We have a story about kalau pergi ke hutan, so they put the jagung, so to recognize when we want to come back to return back to home. So then we just identify or recognize the corn or jagung, and then to find the shortest path as well. So as they move and deposit the pheromone. So this is the chemical things generated by the ant. Swarm robotic, source of inspiration. So this is the also inspired by the behavior of organism, collective organism. So we can see the application environmental monitoring. So it is related to Dr. Sapto, maybe about the environmental monitoring. So we can use the swarm, robotic to monitor the environment. It's one example. We can design fish, kind of fish, robotic fish, maybe we say. So to work and put in the sea, in the certain level of sea, and after that we can monitor the movement and got some data from the activities of this fish. So in order to get more data, so we can put many fishes in this case. So then we can generate more data based on these activities. And then there's the other application about the coordinated tasks. So like ant in this case. So ant, when they found the big food, yeah, they will call the friends, yeah, the colleagues, yeah, ask them, okay, help me, we have a big food. So then they will come, yeah, to the friends, yeah, I mean to the end, yeah, the ones found this food, then after that collaborate, yeah, to work together to bring this food, right? So we can see the video, this example of swarm robotic in terms of the collaboration or collaborative work. Can you see the video?
Yes, we can see the video.
This is a good example of the swarm robotic, yeah, collaborative work based on the animal behavior. Yeah, let's say based on ant. When ant found the food, then they will ask, yeah, their families or their friend to come and to bring together. The small robot can recognize, yeah, which one need need more power, yeah, to bring this kid, yeah, because of if only 1, 2, 3, 4 robots, yeah, if they cannot move this kid, yeah, from one location or one position to the other position. When it is enough power, then they start to move. Yeah, so then they can recognize these things. Yeah. Okay, good. So, and about the time is continue or I have to.
Sorry, I couldn't hear your voice clearly, Prof. Anton. The video also.
Yeah, because of the network problem, I think. Here.
Yeah, but it's okay right now, I think. Yeah. Okay, Pak Anton.
Sorry, maybe the next problem here. So during the weekend, I need to resume some slides here. Yes, Dr. Ruli? The time is enough, or I need this? How long you give me the time?
Yeah, actually, for about 45 minutes, Prof. Anton, and then wait.
So how long the remaining
I
times?
think you have 4 minutes. 4 minutes.
4 minutes.
You have
yeah,
4
right.
minutes more. Yeah.
To finish
you have
this
4 minutes more.
Yes,
yeah.
all right. Okay. So the first one I talk about organism behavior. This is the second one, inspired by organism structure. So one example is artificial immune system. So what is the concept of the artificial immune system? Immune system is actually, the living organism must protect themselves in terms of immune. I think this is you understand about this immune, because I don't need to explain about this, the immune detail. And then what is the application of the immune system? So the function of the scientists try to imitate the function of the immune systems. So immune system must detect the pathogens and eliminate the pathogens, the virus, bacteria, and so on that attack the human body or the organism and so on. So then they created the artificial immune system, AIS. So or to protect the network, for example, or protect the computer, right? So nowadays we use antivirus in computer. So then later they will apply this kind of thing, artificial immune system. So we don't need to install any antivirus into the computer, because they have self-defense. I mean defender, or self-protection. They create by using the AIS. They create the immune for the network. So then they can protect. So it is imitated by or inspired by the organism. So then the researchers created the immunotronic. So this is the application of the machine. That probably can defend from the attack of the virus or attack from the outside mechanism. They try to like intrusion detection, and so on. And then the last one is inspired by evolution. So one example is, so this is actually how to replicate for the graphical array, FPGA. And so this device later can reconfigure when they face the problems with the circuit and so on. So then they can reconfigure. Then after that solve their own problems. So this is electronic. All right. So I think this is my presentation. So the conclusion is the approach and example. source, as a big source of the inspiration, for design of the intelligence system, that capable, more efficient, in terms of autonomous operation, especially for unknown and changing environment, dynamic environment. And then practice of bio-inspired artificial intelligence requires a scientific effort, in terms of to extract the principle of biological intelligence from the data and theories, especially provided by the biologists in this case, and as well as collaborate with engineering counterpart to translate the principle and function into the artifact and the technologies. So this is the reference, and thank you for your attention. So I give back the time to the moderator, Dr. Ruli. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Anton. You inspire us so much. So now we understand that the biological system, I think we can say that biological system is the one of important inspiration for artificial intelligence. As you explained before, that all artificial intelligence inspired by organisms, even for artificial immune system and artificial inspired by evolution, so many things. I hope our student can be more confident after this session, because we learn biology, and then in I want to inform also in our new curriculum, all students in not only in Undip but in Indonesia. So the Internet of Things will already be of the new course for especially for new students since last year, I think. So this is a very relevant our topic today. Thank you very much. Then for next session will be session from Dr. Sapto. So for session the question, of course, many question I think to Prof. Anton, but just hold on. We will have a special session for question after Pak Sapto. Okay. Now I will read the curriculum vitae for Pak Sapto. Okay. Sweet. Yeah. Yes. So Dr. Sapto Purnomo Putro, M.Si, Ph.D, is one of our lecturer here. He is an associate professor at Department of Biology, Faculty of Sciences and Mathematics, Diponegoro University. His educational background, he got bachelor degree from Studium University in 1992, and then he continued for his master degree in Institute of Technology Bandung, in 1999, and then he got PhD degree from Flinders University, Australia. He got his PhD degree in 2006. And Pak Sapto started his academic career in Undip, and he has many experiences as technical assistant staff of Vice Rector for Cooperation and Development in 2007 until 2010. And then he used to be a director of Undip international office in 2010 until 2012 or 11, and then as a coordinator for cooperation and development in Faculty of Science and Mathematics, and then he continued as Vice Dean for Research and Innovation in Faculty of Science and Mathematics until 2019. Pak Sapto also received many awards. Yeah. For example, here he appointed as and he got award for penghargaan 110 karya inovasi Indonesia ya paling prospektif ya, in 2018, and then penghargaan sebagai dosen dengan dana riset terbanyak kedua Undip tahun 2016. So we can say also Pak Sapto as Sultan ya di bidang risetnya ya. Dana riset terbanyak ya Pak Sapto ya. Okay, and then also penghargaan sebagai dosen berprestasi tingkat 1 Undip, and then he continue as a finalist ya, dosen berprestasi tingkat nasional. Di final ya, dosen berprestasi tingkat nasional Pak, berapa rubber set apa straight set ini waktu itu? Okay.
10.
Then he got award for excellent paper international conference on applied life sciences in Konya, Turkey. Yeah? And then he got a COSDEF award for his quality article published in Journal of Coastal Development. Then not to mention, Pak Sapto, of course, already published many papers in reputable international journals, I think, and then he got many research grants. Yeah. Okay, Pak Sapto, this is your time. We allocate 30 minutes for you to present your topics. Okay, Pak Sapto, it is your time.
Okay. Thank you very much for Dr. Ruli Rahardian, as moderator. It's really a pleasure to me to share part of my research project that we conducted within the last 5 years. And allow me to say thank you very much for my friends, my colleagues, Prof. Anton, Satria, who are willing to share the very good information, very good cutting edge of the technology, IoT, which is really useful for the students of biological science, as Pak Ruli mentioned, that inspire a lot for the students hopefully to improve, and then someday they will get involved in the IT projects invited by Pak Anton someday. We don't know. Anyway, please allow me to invite Pak Suki, Mas Suki, just to show I already delivered my presentation to him, so hopefully he can handle it. Mas Suki, could you please to open the presentations? Hello, Mas Suki, are you okay? If not, I can share it from here. That will be okay for me. Hello,
sir,
Mas
I
Suki?
have problem. I'm sorry.
Okay, so I will help you, Pak Sapto. I will share my screen.
Okay, that's okay. It's okay. No, it's okay. I can show me the screen of my presentation.
Okay, just in case you got a problem also, I will help you.
Yep. Hopefully it's okay now. It's okay. I can do it. Yeah. Yep. It will be okay. this one. Yeah. So, Baruli, allow me to share from my laptop about.
Yeah, I think you already started screen sharing. Okay.
Presentation now.
Already seen. Okay.
Okay. Yeah.
Yes. Okay.
So, as a part of our commitment to, developing the software for biomonitoring as early warning system in an ecosystem of water, of water ecosystem. Actually, this is a part of the 5-year project that we hope that this will be easy to understand, because I involved also, this project is involved by some of the colleagues. One of them is Pak Satria from Information and Communication, Ilkom ya, ilmu komputer ya. And before that, let me introduce the background of this distribution of marine lifestyle. We start from the fact that 16.7% of the earth animals are marine, right? And then 2% inhabit pelagic environment. Most of the ocean are solid dark. But surprisingly, 98% are benthic. What does this mean? That it means that some undercover of the animals are unidentified yet, because most of the human only recognized pelagic environment. Yeah. And some of the pelagics actually as plankton and necton, and then benthic as demersal and epifauna and infauna. Yeah. The benthic itself tend to be demersal. It can be epifauna and infauna. What are they? They are, for demersal, they are swim and rest actually just surrounding the sediments under the water ecosystem, like shrimp crawling on the up of the what you call sedimentary habitat. And for epifauna, they attach to the corals, attach on the surface of corals, animals, starfish, for example. And the others are infauna, for example, tube worms, cucumbers, and other animals to have ability to digging a hole or make a tube for the house into the sediment. Thoroughly, along with my presentation, let me, if my speak is not real, okay, because of the internet.
So far,
for the basics,
that's clear enough.
Okay. Okay, thank you. Yeah, the benthic organism are those that are live on the ocean floor. It's already recognized before that 90% are known marine species are benthic. For the vast majority of the benthic species live within the shallow continent shelf. So you can imagine that how diverse the species of benthic are. When we're talking about the intertidal zonation and organism living on the intertidal zones, maybe some of the audience don't really understand what is intertidal zonation. The intertidal zone is a zone that is from the highest high tide of the coastal area to the low tide of the water of the ocean. So that's the interval of that. That's the way we call it intertidal zone. So here we can see that the diversity of the animals, benthic animals, can be epifauna, infauna. They it's quite different, and they tend to be differ by the zonation. Let's say for example, like Litorina, Limpet, Ikia, they tend to be in the highest what we call coastal area, close to the land, which is for the low tide zone. We can see sea arsine, for example, and then also algae, and also the algae is not a part of the microbenthos, but they're living there. And sea star, for example, as an epifauna, and sea anemones, and it can be many things there. Most of them are body organism and algae. They are living there. So because of that, we recognize the diversity and the structure community of the macrobenthos that can be used to assess the level of disturbance. We make a sample of this, the potential risk of fish farming practice, for example, here. It can be many things. For example, increased number of farm cage, and because of the water currents getting slow, and increased sedimentation, and organic enrichment also can occur, and then further result in eutrophication, fast growth of weed, potential algae blooming, yeah? And then this situation can be worse because of limited knowledge of the local society on the ecosystem when they are doing farming practice. That's why some of the unfit fish pellets are deposited underneath of the farm's facility. That can be a danger for the farm biota itself. So overall, that can be decrease the water quality, especially dissolved oxygens and pH, and then or increase organic materials as well. So that's why we need to biomonitoring application to know, to have better understanding of the situation. The biomonitoring itself is an evolution of the condition of water body or ecosystem using biological agents with survey and other direct measurements of the resident biota. That means that the certain time we need to assess the ecosystem by using biological agents. It can be many things, can be plankton, and can be fish. It can be also a macrobenthos. It can be many things living in a water ecosystem. And then they can be used for direct measurements, yeah, to assess the level of disturbance. So for my competence and my expertise in benthic macrobenthos, that's why we focusing on this. And they are inhabit in bottom substrates, or at least part of their life cycle. It's not always all the whole life cycle they're living as macrobenthos. It's only certain part of most of them are certain part of the life cycle. In the larvae phase, for example, they are planktonic usually, like polychaetes and crustaceans, some with crabs. They are planktonic before they become adult. So why macrobentos as a agent for biomonitoring? Because I mentioned before, they are affecting directly the physical, chemical, biological condition of the water ecosystem, and then they can step to the pollution. They can be easily, impact on the by pollution. So because of that, because they can't even move fast like Nekton, right? It's just crawling, and then sometimes they are sedentary life. They are living in the part of the life cycle in just in a sediment, so that this can be easily, exposed by pollution. So the effect of short and long-term pollution events, it can be detected by the dynamics of the macrobentic assemblages. So they also can show cumulative impact of the pollution because the benthic animals, some are bioaccumulator. Some of the pollutant can be absorbed in the tissue of the body of the benthic animals. Yeah, and then because of that, they change the structure and measure the impact in habitat loss. This can be used as bioindicator as well. So the other things that the benefits of doing using macrobentos is a critical part of water ecosystem of food web. They are very important. So relatively easy to sample and identify. Usually we use coral or crabs. The technology of coral itself is developed quite well. And some of the laboratory in England and Japan, also in the US, they sell coral is quite good. And then also grape. It's very famous grape is Ekman grape. And the other thing is about they have greater diversity in water ecosystem than other animals, like such as fish. As I mentioned before, 98% in the water ecosystem consist of the animals, this animal. And we're talking about biomonitoring, or what level we can usually do. We can usually do in organism level. It can be biochemical, can be learn or assess in physiological, morphological. Like I mentioned before, when the bioaccumulation occur in the tissue of the animals, we can do the physiologist or biochemical. And even life history or bioaccumulation, we can do that. And in the population, we can assess the biotic index multivariate. What we are doing now here is in community level, which for the development of software later I explained is we based on the taxa richness enumeration diversity index, similarity index, biotic index, and the combination level, for example, structure of food web. Actually, we can do that, but it's quite complex for the ecosystem level. So, yeah, we do this already. Hang on. For the sampling, or we just some the case of the project is located in the area of Karimun, Jawa, in Central Java, and then we usually, as a part of the assessment, we usually two sampling location with 3 station, 3 replicates as a standard, and then we just to run and took the samples of that 2 different locations, just see how the difference between the structure between the reference. The reference itself is the area that are not disturbed from the aquaculture activity, for example, or human activity. It can be at least 1 kilometer away from the human activity or aquaculture activity. just to make sure that the natural situation that can be compared to the disturbed area. Here the standard of the assessment of the biomonitoring, that can be used plankton net or Ekman grip, and using in situ water quality assessment. Usually we use multi-prop Horiba UCP. Then we try to get the sediments and bring to the lab, and then try to use the some of the steps. Yeah, there should be fixed in formalin 10%, and then they try to rinse, and then they have to be sorted, yeah, under the microscope, and then we preserve in ethanol 70%, and then start to doing identification. For identification itself, we usually using stereo microscope. It can be in our lab. M.Si, we have SMZ 25, which is quite good, and then it's quite modern enough to identify the macrobenthos animals. Here we go. The animals, it can be hundreds or even thousands. We just show the audience only some of the animal, which is quite interesting, how diverse they are, and then it's different in shape. And for the polyheads, we try to identify in the head of the polyheads to identify first the head. They have ornaments, like they are different in ornaments, occipital antenna, and some of the appendix, so they can be easily identified by using a reference book, identification book, and then it's in some other belong to at least 5 phyla of the animals. What is the next when we collect the samples and they do enumeration, and then they categorize in the based on the class, for example, or even can do it in family or species. And then we try to categorize in the simple way is using pie diagram. And then what happened in a pie diagram, we can actually cannot, conclude many things using pie diagram. We have to have some of the what we call analysis further. Here, for this example, we just try to selection of dominant taxa to see whether they are, responsible for the difference, the position of the ordinates of the sample. Here is just the one bubble is one station, and you can see here that the more, for example, here Spionidae, and they tend to move away from the other station, indicating that they are responsible for the difference between one station to another. For the multivariate analysis, for example, yeah, I have license primer 615. Actually, now it's already on sale, maybe more than this types, because I bought this a long time ago, but it's still very powerful to identify the difference. How to make it something important and recognize the difference. For example, here, I use for you here for the species rank and cumulative dominance. And the more curve in the upstate, that means the more they have dominant taxa. For the dominant taxa, for the community level, that's indication of the disturbance. When they have dominant taxa, there must be something, it's not what we call normal. it's something disturbed in that area. For example, if the bottom here, that's mean they are more diverse and less dominant taxa. It is very simple to identify whether or not the station are disturbed or undisturbed using this cumulative dominance. Where other, we can also combine with an MDS. Here, for example, non-metric multidimensional scaling that allow us to know whether or not our samples area are clustering. For example, here is very clearly cluster. What kind of data we use here? It's just abundance and what we call species. The kind of species, yeah. Number of species and then abundance. We put the data, and then we can see here indicating that the reference area a difference with, for example, here in aquaculture area. Yeah, the two. And another thing here is it's very interesting to use this abundance biomass curve. What data we use here is first is abundance like this, but we need to have additional data, which is biomass. So theoretically, if the biomass is upper the abundance curve, that means that the station are in normal condition, undisturbed area. While in opposite way, if biomass is under the curve of abundance, that's mean indication of heavily disturbed area. When they are intercept, that's mean middle disturbed area. It's very simple, and then this been found by expertise in ecological statistics. Yeah, so it's very powerful to assess using this, and then also this is the bubble plots of dominant taxa. We can use it. It's the trend that is very clear that the more we get the sample of certain species, the more they try to move from the group. You see here, that's mean they are responsible in the disturbance, the indication of that. For the software that we have developed, it's a early warning system, 3SWG. That's the code of the inventors here. The inventor is an initial of the inventor. Actually, it's an ecological assessment for water ecosystem using microbentic assemblage. So far, unfortunately, we only focusing on macrobentos. We are thinking to have another software assessed using plankton. The data is still collecting. We need to have a lot of data to make the software robust. So the testing of robustness also, we have to use it to make sure that in any situation, the calculation, it should be stable. You know, here the user calculate the system in software. Be headache to calculate. Allow this. Let's software to do our job. So just make it simple, and then they will be released. All the what is the data can be used here is a biotic, which is macrobenthos, and abiotic component. It can be water quality assessment and its sediments properties. It can be sediments composition. Yeah. And then also another thing is about maybe organic. It can be C or nitrogen and phosphate. We can put it there together, and even further, we use already the diversity index put together with evenness and dominance index put together, and we are using simple weighting of the calculation, and then it put in the system. The output will be calculate the level of disturbance, and then the recommendation needed to be done for the further what we call step. So yeah, the phase, what we call the windows of the step of the software, which is the quite simple, and then put everything here, like for example this spionite, and then what species we can have, and then put how many number, how many number, and then everything put in here, and also index, and can be water quality, and then put together, and then the result will be refilled here as a conclusion. And the conclusion status here, for example, likely disturbed area. That means all of the data, biotic and abiotic data put together, and then the calculators say that your station are likely disturbed area, or even heavily disturbed area, depending on what you have found in terms of the water quality, sediments, and also biotic structure. All right. Then here also the recommendation. For example, here the recommendation further monitoring for more maybe samples. We can use it more frequent. We can assess to make it more clear that the station are, for example, heavily disturbed, undisturbed. Yeah. So here a part of the project also we have already, make what we call integrated multi-trophic aquaculture. Here we have fish cages that have been developed for about 10 years, and then collaborated with the company, and then we make here in nicely settled in Menjangan Besar Karimun Jawa, and some 2-3 other parts of the Indonesia, in the, for example, Kepulauan Seribu, Jakarta, and another area is in Riau, and also in Bintan. So we try to introduce what we can do as a researcher to introduce to what we call sustainable aquaculture. So where the other, we use usually some farmers and other businessmen using monoculture with the square. It is okay, but sometimes for the long period, there will be a problem with the environment. If we watch, for example, the sample in Menjangan Besar, if we see like that, the pie diagram of the percentage of the biota, sometimes we are difficult to understand what is implication of this data anyway, because it's look like the same aquaculture area and reference sites. So we have to have another assessment to know what's going on with the aquaculture area or reference area. That's same. Actually, when we use the symbol like this, we cannot, conclude. We can only conclude that the reference area and the aquaculture are the same, actually. But when we run, as before I explained, when we run that, it can see here that for example, reference area there underneath here, it seems like indication station has the most diverse area compared to other station. See, so that's the sense of recognizing using this dominance curve. It's quite easily to understand and to know. And also here, there's a clustering actually by non-metric multidimensional scaling. We can actually within reference and aquaculture area, actually they are different in structure as a whole. And also by time, it seems like by time and also changing the structure. So the dynamics of a macrobenthic structure is very complex. They are spatially and what we call spatially different someday, and by time also it's quite different. But the pattern sometimes annually that could be the same, but all are depending on the abiotic factors. for the result of, for example, by assessing using AWS software, we can conclude here that the some area actually even like monoculture and reference area has been moderately disturbed area based on our software. So this is quite quite meaningful to conclude something the station and using this software. This is the part of the process of the aquaculture farming activities. Yeah, in some area we did in Pulau Seribu here, and some area in Pulau Menjangan Besar and Riau, and that's the harvest that we Bawal Bintang, a pompano, and it is grouper. It's quite expensive. Grouper 1 kilo is more than 100,000 rupiah, so it's quite valuable. Here the what we call the reference books that I already introduced, and this book actually will be gift as a gift for you who are having good question to me, and then for the good question, for the best question, I will give this one for free and will deliver to your address, and committee will organize for this. And also another question for the good question, I also give this actually is a module of manual procedure application of biomonitoring using software AWS. Yeah? So that's, I think, all I can say for this just information about how we are focusing and have a good commitment to to do sustainable aquaculture. So thank you very much. Back to moderator, Dr. Ruli Rahadian. Thank you.
Okay, thank you very much, Pak Sapto, for your presentation. I think you already explained many things about marine ecosystem especially, and then related to your project to develop special or specific software for biomonitoring, especially for early warning system. Yeah. Then, as we know, that many problems related to fish farming practices, right? Then then you use macrobentos, yeah, which affected much by physical, chemical, and biological condition of aquatic ecosystems. Then also including pollutant, right? Then your solution is the spatial software, yeah. So you develop a specific software which could determine the environmental disturbance, especially for marine ecosystem, yeah. Then I think this time it's time to move to question and answer session, yeah. So I will open question directly. Any participant who want to ask to Professor Anton or to Dr. Sapto, you may raise your hands, or you may write your question using chat room. Yeah. So while I'm waiting, okay. Okay, the first question from Ali Utomo. Okay, Ali, make sure to unmute your microphone.
Okay, could my voice be heard?
Yes, I can hear your voice.
Okay, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
First of all, I would like to introduce
Waalaikumsalam.
myself first. My name is Muhammad Ali Tomo. Usually my friends call me Ali. In this good opportunity, I would like to say thank you so much first to Mr. Ruli Rahadian that for your time, and also I would like to say thank you so much to Mr. Anton and also Mr. Sapto Purnomo Putro about your material. I think it's very interesting and also very amazing material that can open mind and also can open my eyes because today I can find relationship between my majoring in biology and also in artificial intelligence. But I have a question, Mr. Regarding to your presentation, especially about the biomonitoring system. Okay, if we talk about artificial intelligence, I think it have a close meaning into an application on a or a machine and also about the robots. But I think if we do some analysis about the environment for the application and also for the machine, it can be still accurate, sir. About the accuracy and also about the time, it's still accuracy and still acceptable because we know that for especially in a environment condition, yeah, it can change so fast, yeah. But if we do some hello?
Yeah, yeah, Ali. I still can hear your voice.
Yeah, I got trouble with my voice, but okay. So I would like to ask about the accuracy, Mister.
The
How long it
accuracy.
take, and then also, is there any side effect if we use any artificial intelligence for our analysis, especially for the biomonitoring system? Thank you.
Okay, Ali. So you deliver the question to who? To I think to Prof. Anton, right?
Yeah, between Mr. Anton and also
both.
Mr. Sapto.
Okay.
Both.
Okay, to Prof. Anton and Sapto, yeah. Okay, your question about the accuracy of artificial intelligence, especially when we use it for biomonitoring. Yes, for biomonitoring in ecological, in ecological system, right? Okay, first I will go to Prof. Anton. Prof. Anton?
Yes.
Could you hear the question?
Yeah. I heard the question. All right. So yeah, very good question, yeah, from Mr. Ali. All right. Yeah, actually about talking about the accuracy, right? So it depends on because of when we develop the AI, so we depends on the software, the first one, and the second one hardware, right? When we want to acquire, I mean, take the data from the environment, yeah, acquire the data, yeah. So we need to find the suitable or appropriate device, right? Because we need the sensors. So we have to identify what kind of features that we want to detect or recognize, as for example temperature, for example size, for example the speed, many things. So what kind of features? The first one is what kind of features that we want to detect, yeah, to recognize. So it depends on the sensor that we select, yeah, to put, yeah, on the system. Because of why I talk about the sensor, because sensor is the first device that, you know, take the data from outside. So sensor actually, yes. The work of sensor is actually based on the transduction system. So it will convert one energy or one form of energy to the different kind of energy. So in this case, it will, for example, vibration, or wave, it will convert the wave energy, to the electrical energy. That is the sensor. I mean the transduction system. So we have to select the good sensor, with the high accuracy. Depends on the specification, because so they will provide the specification. Many vendors provided this kind of things, so you can ask them, and many brands, of this. So but then the important thing, you have to know what kind of features that you want to detect or to recognize. So this is the accuracy. And the second one, the software, the hardware, and the second one is the software. So we have to, to find the reliable software, because so there is many software in, in the market. So even Google, they have AI Google system, and Azure, Microsoft, also they release the Microsoft Azure, and TensorFlow and many things. So we have to study and compare which one the reliable software available. All right. So then after that, then we can get the good accuracy. If even Amazon, they provide the Amazon web services. So then we can train our system, our algorithm, for example, machine learning algorithm, into this kind of software. So because of currently we have many things cloud system, in the cloud system. So we can, run the server from outside. In terms of the data, of course, for the environment, there will be the big data involved, because of, maybe you need every second, every minute, the change, the environmental changing. So that's why you need the good big data analytical. So in this case, you have to find the good sensors and to find the good software, the reliable software. So that's why, but it is possible to get the very good accuracy to detect the environment. As long as we can find the suitable or appropriate sensors, the device hardware, and also the software. That is the first question. And the second one, actually, for the impact, the benefit. So since the algorithm is not easy to develop, so we have to find the appropriate one. I mean, because so if we have only a small system, then it is not necessary to to develop the artificial intelligence. So we can use the simple algorithm like if then rules, or maybe like the ANOVA and so on. So no need to create the complicated ones, because so when we use artificial intelligence with the big data, for the current the current situation. So that means that we have to provide also the high performance computation or computing. So we have to provide the high performance computers, so with the high performance server, and then with the high specification or high end technology of the computers, like the laptop or maybe the PC and so on. So that is the requirement. So otherwise, then also you will not get the fast or real-time result. So because of, in the case of the environment monitoring, I think we need the real-time monitoring system, right? So exactly at the same time, we can get the information from the outside or the environments. So then there are many benefits we can get from the AI application, especially the machine learning, because so machine learning is based on the learning. If we train the system, as many as possible, so then we can get the more accurate. So if we train, like a Google engine, if you use a Google engine, search engine, if there's many people use this kind of tools, so then then the Google engine will increase, the accuracy will be increased automatically, because so this is the typical of the machine learning. They have the capabilities to learn by themselves. I mean, in terms of the supervisory or unsupervisory learning system. Okay, that is the answer for the second question.
Okay,
Thank you.
Okay, thank you, Prof. Anton. Then for Dr. Sapto, maybe you may add some more information about the
That is okay.
biomonitoring software.
Yeah,
How
I've just
the accuracy.
mentioned that. The accuracy actually has been answered by Prof. Anton regarding the tools. What I mentioned here that the artificial intelligence, as mentioned by Prof. Anton, it can be used to assess the biomonitoring. We are looking forward really to have kind of like fish robotic, or because this is maybe if we have kind of fish robot that is all of the chips of the probes, for example, of quality of the environments, including, for example, water quality there, and then the fish can be swimming around that area. This is very useful. I really want to know whether the fish robots is already produced or still in developing. So another thing that we know already, it's about I think remote underwater vehicles, or ROV, I think. I'm not, if I haven't mistaken. It's been developed. I think that we can actually use underwater vehicles with the remote system. They can actually, photo some of the sediments underneath the water ecosystem that can be not easily achieved or not easily accessed by human. That's very useful. And then let the robot to communicate with the environment, as mentioned by Prof. Anton, that maybe the robot will collect the data, and then when we retrieve it, and then all the data of biotic as well as abiotic, that can be calculated and then can be collected. I think is it all right, Pak Anto, for this possibility to have robot
Yes.
for
This is
biomonitoring?
a challenging
But the
project.
accuracy, I really agree that the more we use it, the more the accurate, because data entry will be making the software is getting robust. Anton, maybe Pak Ruli, maybe they may respond for my challenge. Thank you.
Okay, thank you.
Okay.
Prof. Anton.
Okay.
Ali.
Okay, Mr. I can got it. The main answer from Mr. Sapto and also Mr. Anton too. I think it's different to our subject of our research, our specification research. For example, like if we wanted to know about the temperature, we will use like sensor, and also for if we wanted to capture or take a picture about the basic animal, we can use tools like voice robot, like Mr. Sapto, Putro machine. Okay, thank you so much, Mr. for your answer.
Okay, thank you, Ali, for your question. We'll continue to another question. There are two questions for Prof. Anton here. The first one from Kiara. I will read it. Excuse me, Mr. Anton, I want to ask, in the robotic fish project, it can be used to monitor pollution port, make a map pollution level, and so on. So my question is, how long it takes to get the data? How much accurate of the result? I think this is the same with the previous question, the accuracy. And are there any factors that can affect the works of the robot so it can give wrong data? Thank you. Maybe one by one, Prof. Anton, you may answer for this question first.
All right. Okay, so interesting question again about the accuracy. Yes, Accuracy is actually depends on the device, the device and the hardware and the software that we use. So, and then also the algorithm. That's why in this case we have to study about the algorithms to compare the behavior of the algorithms that we use, because of some algorithm maybe it is not suitable for the certain application, especially for the machine learning or for artificial intelligence, because if you only involve the small data, so then not necessary to use the artificial intelligence. So in this case, so I assume that we need the so much data. I mean, in terms of the big data. So if we need the big data, then artificial intelligence is the solution, especially the machine learning, right? So in this case, by the machine learning, we can collect the data even real time. This is the point. So real time data, I mean real time information is very important today. So that's why, so when we use the AI in this case, to collect the information, then we can get the real time data. So if it is long distance, maybe there is a less delay, like maybe only in the range of the second, less than 1 second, something like that. It is normal, for the device, but we can get real-time data. That is the first point. The second one, so means that it takes, it doesn't take a long time to get the data. Immediately you can get the data. Like you upload the information, you upload the status on Facebook, immediately we can get your status at the same time. That is the same thing can be applied to the environment. Immediately when the sensor capture the information or acquire the data, so then immediately we can get the information and the data. That is the same thing. Like if you use the social media, in terms of maybe the famous one, Facebook or Twitter and so on. So immediately, no need to wait. Immediately when you upload the picture, for example, then immediately many people, if you broadcast that information, then many people can see the information that you have uploaded. That is the things. And then about the accuracy, as I mentioned before, so it depends on the hardware and software, and of course the algorithm that we choose, we use. And then the factors that can affect the robots, in terms of the decision or give the wrong data, it is possible. That's why if we use the swarm robotics, so then because of many robotics, so then if one, for example, if one battery finish, if one robot the battery finish, so then the other robot, we have the other robot, so many robots, so then no need to worry about that, about the hardware. That's why if one robot collapse, for example, or broken, due to the battery finish, or maybe something happened with the the hardware on the robot, so then the other robot will take over the job, the work. So no need to worry about that. So in terms of the hardware, we can settle, but then the other condition or environment can affect to the monitoring system is I think the weather, the weather. If it is a long distance, for example, with the heavy raining, so then it influence the affected to the data that we receive from the robot, because we use the electromagnetic wave, maybe using the high frequency, like GSM, using the GSM, for example, Wi-Fi and so on, long distance range. So then, but then it is actually reliable waveform, So even there is a heavy raining, only in certain circumstances they can affect to the communication. So no need to worry. So nowadays everything is fine, with the environment, as long as we can manage all the devices and the platform, the application. Yeah, but the most important thing is the funding as well. Yeah, because when you select the good devices, when you perform the good software, so yeah, of course it costs a lot, too much, but it's fine. Yeah, Dr. Sapto, got so many, the big grant,
Funding.
so that's why, having lot of money, so no need to worry.
Unfortunately, in rupiah, Pak Anto, it's not in real.
So okay, that is the answer of the question.
I think rupiah is better than yen, Pak Sapto.
Yen or not Twitter?
Yeah, no.
Okay.
Okay, Prof. Anton, thank you. And then for the second question from Andriana Kusuma. Yeah, I will read it. Excuse me, Mr. Anton. Let me ask a question. What is the first steps if we want to learn about artificial intelligence? Is there any software could help to study artificial intelligence? Yeah, thank you.
Okay, thank you. Good question. All right. So I'm not sure whether you study about the artificial. Is there any course related to AI in biology department?
I don't think so, but we have a Internet of Things for first year students.
Okay.
Yeah.
Because I think artificial intelligence and big data is more useful in my opinion. Yeah, as well as IoT, because IoT is part of the current technology.
But we introduce also the big data and then artificial intelligence.
Yes,
in Internet of
because
Things course.
all the things today we use the AI and also big data, even when we use social media as well.
Yeah.
So about the software, about the first to learn actually the basic things of AI is mathematics because of, and also for the today, so we have to learn about the biology. So you don't have any problems with the biology because biology is the important thing for us. Yeah, when we develop the bio-inspired artificial intelligence. That's why every time we ask the biology people to talk, to deliver the lecture about the behavior of animals, behavior of organism, and so on. So then we can learn and we can develop the algorithms based on that knowledge, this knowledge given by the biology people. All right, so the mathematic, and I think you don't have problem also because you are under Faculty of Science and Mathematics. So and then for the software, because of software nowadays, the big company provide own platform, like for the machine learning. Amazon, they have a platform to develop the machine learning, and then Microsoft also, they have a platform. But I think we need to pay the subscription. That is the point. Maybe if they give us the trial, then maybe only the very limited features or application, just to see how they can develop. I mean, how we can organize the algorithm by using this software, this application. Microsoft, Google, they have TensorFlow. They have the platform to develop the artificial intelligence. So first you can find on the website, of course, Google. So try to understand the term one by one. So now it is not difficult, I think, to study about these new things for us, because everything is on Google. We can see. So but then the problem, that is normally for the subscription, because they ask to pay the subscription at the beginning, unless if the university provide the software for study, so then it is very good. But then long time ago, 20 years ago, I used MATLAB, but nowadays MATLAB is not really suitable, especially for the heavy data, yeah, for the big data. Yeah, but for learning, it is still okay, still fine, like a neural network. Yeah, but in terms of deep learning, then you need the more than the available. I mean, the MATLAB and so on. So like TensorFlow. Yeah, because so it involves the big data. Yeah, big data. In terms of data, maybe petabyte, yeah, zettabytes, not in terabyte anymore. Yeah, in petabyte, zettabyte, and so on. So that's why. Yeah, so gigabyte, terabyte, and then petabyte, and yeah, until the zettabyte. So it's a very big data. Yeah, so it is very useful. Yeah, I think you can learn also. Yeah, here there is some student from biology also studying PhD, master PhD, and they handle about the big data as well. Yeah, because of they collaborate with the counterpart, with the groups, yeah, of the research, and then they develop the algorithm based on the organism behavior. Yeah, this is the information, right?
Okay, thank you, Prof. Anton. We still have 4 minutes actually, and then no more question in chat room. Even no more raise hand also. No. So I have a question for Pak Sapto. Pak Sapto,
yeah.
Do you use artificial intelligence also in developing your software?
Yeah, actually, I don't know what is the terminology for that, but I think we're just using, these many parameters of abiotic and biotics and put together, and then they kind of using Satria, yeah. They and they actually he used like a weighting system to make sure whether the parameters are valuable, how much valuable to identify the heaviness of the environmental disturbance. It's depend of the some sort of, for example, animals are as bioindicators of the environmental disturbance. We put a very high what we call score. For example, if the samples we found two defects for the lake water ecosystem, for example, we put two defects, we value two defects as 5, for example, while in no valuable we put 0. For example, the larva of Styronomus, for example, Baruli, and you're entomologist, and the larva is living underneath the sediments of lake, for example, for freshwater. We put 5 score if the station we found that. But we found something is not valuable, we calculate as 0. So that's will calculate, to assess how far the quality of the environments. For example, we've put data abiotic of DO, for example, DO is naturally level 7 as neutral, as pH, for example, or DO. Then we found in a station is 4, for example. So we score that value is 5 because this actually value is it's indication of the disturbance itself. So everything is abnormal, we put highest score. Then software will calculate there. So I don't know in informatics terminology, I don't know what is system, but it's like using that calculation for the of a weighting system.
Yeah. Okay, Pak Sapto. So you use scoring, right, for developing your software?
SAW, yeah. Simple additive weighting. Yeah.
Yes. Simple additive weighting, yeah. Weighting, yeah. Yes, correct, Anton.
Okay. Then in my experience, sometimes, this is also for Pak Sapto, in my experience, sometimes the abiotic data and biotic data, I mean the trends of the data of abiotic data and biotic data could be show different trends. Okay, so if this happens, so which one will you choose for your to conclude the and then to assess the environment, whether abiotic or biotic?
Yeah, we cannot, assess one by one. We actually calculate together and put together as a ecosystem. When we calculate the ecosystem perspective, we have to use many data, biotic and abiotic, where we not just depend on one data. For example, DO tend to be low. It should be disturbed area, but it's we still have many data, and we collect together. Then we base on the structure of the animals. For example, let's say a macrobenthos animal. So we will know that if there's something not suspicious, for example, we cannot find any bioindicator of the taxa in that area. That's mean something normal. There's nothing suspicious in that area. Even if you find, for example, seems to be low, the DO, for example, that doesn't mean that the area is disturbed. Because if we only judge only 1-2 parameters, it can be biased and we misjudge for the ecosystem. That's why we approaching the biotic and abiotic together. That's to make more valid, more accurate to assess the level of disturbance.
Okay, so your software could, could detect or could analyze all of the scenarios, yeah?
Yes.
I think very good. Okay. Well, 32 minutes already for question and answer sessions. Yeah, I think it is enough for us. Once again, thank you very much, Prof. Anton, and then also for Dr. Sapto. I think it is very useful presentation for us. So please give a big applause for Prof. Anton and Pak Sapto, even on the virtual applause. Okay, thank you very much. Then I will give, please, the Master of Ceremony, Gendis, you may continue the session. And then I think we only have 3 questions. So I think all of the participants who already had a question will be appreciated, right? Thank you.
Yeah.
Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Sir Ruli. That was such an insightful experience. And as we know, we will have to experience a shift towards a more advanced world, whether we are ready or not. But right now, we have been equipped by the knowledge from this discussion. And once again, we would like to thank Sir Prof. Anton and Sir Associate Professor Sapto for the superb discussion. All right, dear Excellencies and distinguished participants, we will proceed to our next sessions. That would be the announcement sessions. Regarding the e-certificates, we will issue the certificates 1 week after the Studium Generale, and the certificate will be sent through the emails. And another announcement, that would be the appreciations from Biology Department for participants for the attentiveness and the questions. So congratulations for Ali Utomo and Kiara for winning a copy of Sir Sapto's book, and also for Andriana Kusuma for winning a top-up of OVO or GoPay. Our committee will contact you directly for further information, and we really hope that this appreciation will inspire you to always become a better version of yourself. Okay, now, Excellencies, we have come to an end of our Studium Generale. I would like to say an immense thank you to each participant, and also an apology for every mistake made throughout this Studium Generale. I hope the knowledge shared by our speakers can be utilized for greater good. And please stay home and stay healthy. We hope to meet you again on a better days.